The discontinuity between appearance and bathymetric reality manifests itself at the exact moment when the sonic pulse, crossing the water column, reveals abysses where the human eye saw only a harmless bed. This phenomenon, based on light refraction and the opacity of suspended sediments, obscures the understanding of fluvial morphology, hiding erosive depressions that defy the logic of the local hydrographic basin. According to the principles of potamology, the complexity of a bed is not deduced by the serenity of its surface, but by the turbulent dynamics that carve submerged gorges invisible to the visible spectrum. In Brazilian tropical basins, the high load of dissolved solids acts as an impassable optical barrier, invalidating any attempt at empirical measurement without electronic instrumentation. Navigation historians, such as those who documented expeditions through the Doce River Valley in the 19th century, already reported the danger of depth windows, zones where flow velocity and bottom geology create immense topographical vacuums. Side-scan sonar technology thus exposes the fragility of sensory perception in the face of the geophysics of lowland rivers. The architecture of a riverbed is the result of millennia of sedimentary transport and subtle tectonism, elements that superficial vision could never decode. When sonar detects formations that subvert the expectation of a shallow river, it does not just provide technical data, it deconstructs the arrogance of direct observation. Modern hydrometry proves that the abyss often resides where solar reflection leads us to believe in safety. The evolution of hydrographic cartography transcended the rudimentary use of hand leads, reaching its technical peak with the advent of multibeam transducers. These instruments, by emitting acoustic pulses that travel through the water column, allow for three-dimensional mapping of the riverbed with millimeter precision. As recommended by the International Hydrographic Organization, the integrity of this data depends on correct compensation. It is, however, imperative to question the epistemological arrogance that permeates common sense about submerged topography. Human visual perception, limited by turbidity and refraction, often underestimates the geological complexity hidden under apparently placid surfaces. Rigorous analysis shows that blind trust in the shallow appearance of a water body is a reflection of our reluctance to accept that technology exposes the fragility of our assumptions. The use of side-scan sonar systems and multi-beam echo sounders allowed for an unprecedented volumetric analysis of the riverbed. Under normal conditions, one would observe the predominance of alluvial sediments and linear geological formations of natural origin. However, bathymetric profiles revealed morphological discontinuities that defy conventional sedimentology. The precision of the data mitigated the possibility of electronic noise. As pointed out by applied geophysics studies in preventive archaeology, the detection of orthogonal structures suggests a genesis distinct from common sedimentary deposits. The readings indicate acoustic reflectivity patterns that diverge drastically from the silty surroundings, showing anomalies characterized by right angles and large flat surfaces. These records suggest the existence of architectural elements or heavy engineering remains. The identification of these formations imposes the need for a rigorous review of historical structural interventions in the region. Hydraulic engineering specialists and geologists must investigate whether such remains correspond to buildings submerged by fluvial transgression processes or represent infrastructures deliberately installed in remote periods. The magnitude of the dimensions measured by sonar supports the hypothesis of technical complexities. The visual perception of the river channel, once considered of low bathymetric complexity, proved insufficient against the precision of multi-beam scanning systems. What was presumed to be a homogeneous sedimentary bed of shallow depth transformed into a geophysical enigma when high-frequency acoustic waves penetrated the water-sediment interface. This phenomenon deconstructed the premise of a shallow bottom, exposing deep depressions. One would analyze the local stratigraphy through the prism of classical fluvial geomorphology, were it not for the detection of orthogonal structures buried under layers of silt and clay. According to Charles Lyell's premises on uniformitarianism, current processes should explain the past. However, the magnitude of the concavities detected by sonar points to erosive events of energy disproportionate to the current flow. The reinterpretation of sedimentary geology in this area requires a review of bedload transport models. The presence of dense formations whose dielectric properties diverge drastically from the granitic surroundings indicates that the river channel acts as an envelope for geological or possibly anthropic remains from remote eras. Here, empirical observation fails, giving way to a science that rediscovers the riverbed as a stratigraphic archive. The interpretation of data obtained through multibeam bathymetry reveals a bed morphology that defies current geomorphological conventions. Instead of the expected uniform sedimentary deposit, angular structures of high acoustic reflectivity were detected, suggesting external intervention or a geological phenomenon not yet catalogued. These features in low-energy zones indicate that apparent depth hid structural complexities. In underwater archaeology, such anomalies under consolidated silt point to a chronology preceding the eustatic fluctuations of the Holocene. As observed in archaeometry surveys, the geometric precision of these formations requires a rigorous review of prehistoric occupation records. Academic resistance to classifying these findings as evidence of submerged settlements reflects a methodological inertia that privileges theoretical conservatism. One would question the validity of current paradigms that reduce technological anomalies to mere whims of differential erosion. This scientific myopia, often disguised as intellectual rigor, prevents the exploration of the possibility that civilizations manipulated the lotic environment in ways that conventional historiography refuses to admit. This silence demonstrates an epistemic cowardice in the face of data that subverts the linearity of progress. The culmination of this investigation reveals that human perception, limited by light refraction and turbidity, is often insufficient to translate the geological and archaeological complexity of fluvial systems. Data obtained through multibeam bathymetry showed that under the apparent serenity of a bed, assumed to be shallow, anomalies of unexpected magnitude were hidden. These formations corroborate theses on dynamic stratigraphy. The technical analysis conducted throughout this work reiterates the need for rigorous scientific skepticism. As postulated in applied geophysics, the silence of the depths holds records that erosion and sedimentation tried to obliterate over millennia. The detection of what was once considered impossible under the water's surface represents a reconfiguration of regional cartography. Reality, once decoded, imposes a new understanding. Upon finishing this detailed examination, I realize that you may feel prompted to question what other secrets remain guarded under surfaces we think we know. The search for scientific truth is a continuous process of deconstructing superficial evidence. It would be of great value for you to share your vision and reflections in the comments. Intellectual debate fosters research. I invite you to be present in our next investigation. Until then,